Yes.
Oh,
Oh, yeah. Yeah, okay. Huh?
how's everyone going? Hey, let's get started. Oh, why we have only 4 people today? It's weird. Uh, Today, let's have a look of the Lab 5. There are only 3 parts for this lab. It will take about 20 minutes. At first, let's have a look the documentation of Lab 5. So what should we do in this lab? Basically, it's the same as the previous one, but a little bit different. And you can see a very important concept is the modulation and encoding schemes, which is MCS, this one. If you have already learned this on the lecture, you may know what it is. Basically, this one is related to the data rate, which is the speed of our Wi-Fi hotspot. So let's have a look of a table. Table here. So how can we calculate the like the speed through the MCS index? I think you have already learned what is modulation and encoding, and how can we use this kind of stuff to calculate what is the speed of our internet, what is the speed of our connection. We can use this table. You can have a look of the left side, left corner, the MCS index. There are three different stuffs. The first one is the HT. What is this mean? It means the high throughput. And VHT, what is VHT? It is very high throughput. And HE is high efficiency. So why we have 3 different stuff below the MCS index? Sorry. Why we have these 3 different stuff? Because there are lots of versions for the AO 2.11 protocol. So that is the reason the high throughput is corresponding to the AO 2.11n, which is widely used in our daily life. And the VHT is for the AO 2.11 AC protocol. And HE, which stands for the high efficiency, is for the AO 2.11 AX, which is the cutting edge technology. So you should know which protocol are you using now, so then you can choose the right index of it. For example, we can open a trace file here and select a random packet. And you can find the MCS index is here, which is 15. So how do I know which index should I select? You can see there are lots of index in this table. So which one should we select? So we need to have a look of our AO 2.11 version. For this packet is AO 2.11n, which is high throughput. So we use this column to calculate the speed. So you can find the 15 here. Okay. Then we also need to have a look of the spatial string. So for the spatial string, it's basically it's common. The common number of the spatial string is 4, and for the AO 2.1 AC, it's 8. If you have more spatial string, you will have a faster speed. And for the modulation type, you can see there are lots of different modulation type, but you can see the if the modulation type is complex, it will have faster speed. For example, this one, 256 gram, have faster speed than 16 gram. What is the drawback of the complex modulation type? If you're using the complex modulation, then you are required to have a better condition, such as less interference and a good line of sight environment. Does that make sense? And how about the coding rate? The coding rate is very easy to understand. It's basically the efficiency of your coding. For example, this one is about 83.3% of the data string is being used. And this one is only half data is being used. Okay, and let's have a look of the table here because we are using this table to calculate what is the speed of our connection. So if we have the index information as well as the spatial string modulation and encoding, and we also need to have a look of the frequency stuff like the bandwidth. Bandwidth is 20 megahertz. Then we can choose this one. And then what is the growth interval, the GI? You can see here, it says short GI is true, which means we use the smaller growth interval, which is 400 nanoseconds. So we choose this column and find the 15 of it. Then we can get the speed is 144.4 megabits per second. And then we can check on here. Yeah, it is. So that's how we calculate the speed through the MCS index. So you may need to use this table in your quiz. So for the quiz tomorrow, you may, if you don't know this, I recommend you to have a look of this link. If you are looking for some exercise for quiz preparation, we have a sample here. You can find there are lots of exercise for every week. So you can have a try of this exercise before you attend the real quizzes. Okay. So in the previous table, we just have a look at what is high throughput, very high throughput, and high efficiency, and what is the spatial string, modulation, coding, and orthogonal frequency division multiplexing. So this one is very important. So if you don't know this one, what is OFDM? So you might need to have a look of this video or review the lecture. And I think that's all we need to know before we get started. Let's go to the specification of Lab5. You can see here, there are 3 different tasks in this lab. So we are not going to read through about it. I just have a look up here. 3 different tasks. For the task 1, all we need to do is first one, data collection, and second one is analyze. It's exactly the same as previous lab. The task 1 is what we need to do is just connect your laptop or desktop with your mobile hotspot, and then you bring your mobile hotspot away from the laptop and bring it back slowly and save it as a CSV file. Of course, you also need to apply a filter. And after the collection, you are required to analyze the RSS, the signal strings, as well as the MCS. So what is MCS? We have already learned, right? The MCS index you can find here below the AO 2.11 radio information. So if you cannot find this MCS index, maybe we can discuss later. Yes, so what we need to do is just analyze it. So basically is plot a graph about ISS as well as MCS index, and then analyze the data rate. So you can find the data rate over here is 144.4 MBS. So does that make sense? The task 1 should be very easy for you. Let's go to the task 2. You can see it's basically the same, but for the data collection part, we are required to bring an obstacles. So for example, this one is your mobile phone, and this one is your laptop. Sorry, looks weird, but and you can start to collect the data right now, and then you can push your sofa, for example, a sofa, push in the sofa into the middle of them, and then push, and then pull back. That's how we work. And then analyze this data collection after that. And that's all. So in this task, we just want to observe what is the difference if we have an obstacle between the hotspot and the receiver. But this time we are not focused on the signal strings. We are focused on the MCS and data rates. Okay, just observe the difference on the data rate and MCS index. Have a look at the final task. This one is a little bit complex on the data collection part. You can have a look of here. Connect to your mobile hotspot at first, and then turn on a smart TV. If you don't have TV in your house, you can use an iPad or any devices which can connect to your hotspot, and then play a video on it. And you should pay attention they should be in the same internet, which means you are required to connect 2 devices into your hotspot. Okay. And then you can turn on a microwave oven nearby. So if you don't have microwave oven, so I suggest you to maybe go to a friend's house, or if you cannot find a microwave oven, maybe you need to describe it on your report. Anyway, let us know if you are not able to do this task. So why should we use a microwave oven in this task? Because the microwave oven is also using the 2.4 gigahertz, which will interference the signal transmission. So we want to observe this interference in this task. So what you basically need to do is just connect. Sorry, my drawing is so bad. And this one is your mobile phone, and connect with your laptop, right? And also you connect your another laptop or a TV to your hotspot and play a video, and then you put a microwave between them and turn on the microwave for like 30 seconds and then turn it off. That's basically what we need to do. Sorry for my drawing, so bad. Does this make sense? All we need to do is focus on the MCS index and data rate. And here are some general questions here. It's about the first one. You can have a look of your mark on the previous lab. So if you find any question, just post it on the forum or send us an email. And some students maybe cannot observe the data rate change in task 1. For example, you are doing this task, you like bring your hotspot away and bring it back, but you find there's nothing different on the data rate of MCS. That may be because your hotspots have very high power, so which is pretty normal. But if you can go to the outdoor, you can have a try of longer distance. And some students are struggling to capture the data, the packets we need. For example, you may not be able to capture this kind of package, or your packet doesn't have any AO2.11 radio information in the packet. You cannot find any MCS index as well as the data rate in your packet. I think it is pretty normal. A lot of students cannot capture this kind of package. So the reason is complicated. It may be because your configuration is wrong, or your network interface is not supported, or even your operating system is just not support this kind of capturing. So in case you cannot capture the packets, we provide you a link of some sample data sets here. So you can find the link here. You have 3 different data sets, trace file for these 3 tasks. So in case you cannot capture the package for any task in this lab, so you can use the file we provided. But you are required to like describe the problem you have met in this lab. For example, you are using the task 3 trace file. You are required to demonstrate what is the problem have you met in capturing your data. And there are also comments for these 3 files. You can have a look of them before you use them. And the download link is in the GitHub. It's here. You can see the link is here. I will copy this link to our chat channel, so you can download it right now in case you cannot capture the file, capture the packets we need. Yeah, and that's all I have for today. So do you have any question? So I will stay here to the end. If you have any question, just feel free to ask me. But if you don't have any question, then you can leave. And we'll see you next week. Are the sample dataset captured from Wireshark? Yes. Have we put the microwave between my phone and device? Yes. You should put a microwave between or near your phone and device. Yeah, just maybe you can describe it on your report. And another thing I want to mention in task 3 is maybe you need to make some notes. For example, the first action is turn on a smart TV, right? So you may need to make some notes in which time you have turned on the smart TV and play a video, and in which time you have turned on a microwave oven. Okay, so you can describe it in your report and analyze and make your analyze maybe easier. Yeah, the data collection part may be the hardest one because some computer just not able to capture this kind of packets. So in case you cannot capture the packets, you can use the sample data set. So instead of a smart TV, we can use a wireless USB adapter and use internet from it. Yes, you can. So what we need to do is we want to have more than one devices in your network, and let's see how it works. So basically, you can do it. Just have another device. Because this one is the last tutorial for this week. So if you have like any question or you have met any problem, you can just post it on the forum and we'll reply you as soon as possible. Yeah, see you next week. So the primer is short GI. What the short primer? I have no idea what is this. I think maybe it is not, I guess. So let's have a look. What is the quad interval? This one, quad interval. I think you have already know what is orthogonal frequency division. This one, right? Multiplexing. Let's have a look of this video. So we are not going to watch it, but in OFDM, all the signal is overlapping with each other, like this. Can you see the top side of it? In OFDM, the signal is overlapping with each other, like this. So what is the GI for the interval? Is basically the distance from the top to another bottom. Maybe this picture is not pretty good. Let's have a look of this one. So what is the GI? It's basically from here to here. You understand that? Which means it's their like distance between each other. So the GI is always be at 400 nanoseconds or 800 nanoseconds. It is just the Wireshark display. Is this a difference from your Wireshark? What kind of difference? When you're doing the lab, you can apply the MCS index and the data rate as a new column in the table, so you can easily figure out what is the trend of the MCS index. You can see in here, this one is for the task 1. You can see my MCS index is at 15 at the 0 second, and it drops to the 4 in the middle, and then back to 15 at the end. And you can see the same trend for the data rate. So do you want to share your screen, or because you want to send a picture? Yeah, if you want, you can share a screen. I can stop the recording right now. Oh yeah. So your problem is you're not able to capture the packets we want through the network monitor, which is pretty normal. Because most of the internet network interface is not able to capture the packets we want through the network monitor. Yes, just describe what is your problem, and on the report, and then you can use the sample data set. Welcome. Okay, that's all for the tutorial. I'll stay here to the end, and I will turn off the recording right now.